Hi everyone! Tonight we're going to be learning about dot plots, which might look familiar to you. You might have built them in the past, which we will practice as well, but we're going to focus on really pulling information out of them. So before we dive into that, we need to know a little bit about our dot plots. Okay, here's a nice example. Okay, it says frequency tables and dot plots are used to organize and summarize data. Okay, the data show the number of hours spent by 20 students in preparation for a final exam. Gives you some idea of what maybe you should be doing for your final. Okay, and what they've done with each of these data points is they basically tallied it. Okay, so this person studied 5 hours. Okay, so they put a tally next to the 5. And then this person studied 6, 7, 4, 7, 7, okay, 12, so on and so forth. Okay, and then they counted it up and they said, okay, 2 students studied for 3 hours, 1 student studied for 4, 3 students studied for 5, etc., etc. And once you know that, you can build your dot plot. Okay, so here are the 2 students that studied for 3 hours, the 1 student that studied for 4, the 3 students that studied for 5, so on and so forth. Okay, it's really that simple to build one. Okay, now there's a couple of things you have to pay attention to. This is important. Okay, 12 is what we call an outlier. Okay, you may have heard that word before, an outlier. Okay, it lies outside of the rest of the data. Okay, this is all clumped together and 12 is off on its own. Okay, it's like an extreme data point. Okay, so you have to know that. The other thing you have to know is that, an ideal data set, okay, if you plotted the dot plot, would have what we call like a bell curve shape, okay, where this would be your center. But that's not realistic for every data point. Okay, for example, here you can see what's going on. Okay, and there's what we call a tail, okay, on one side. Okay, so if we look down here, okay, a dot plot with a tail on the left is considered to be skewed left. Okay, and that's what this example looks like. Okay, it looks like there's a tail before we hit our data that's kind of been shifted over. Okay, and if the tail is on the right, we say that our data is skewed to the right. And there's multiple reasons why that might happen. Those are really the basics of what you need to know. Now we can use that to practice some questions. Exercise 1 says Charlie's Food Factory currently employs 28 workers whose ages are shown below on a dot plot. Answer the following questions based on this plot. Okay, so some of these I know you can do on your own. Okay, I'd actually like you to try A, B, C, and D on your own. Pause the video and come back to me. Okay, now that you've tried this, let's see how you did. How many of the workers are 18 years old? Okay, well, here's 15, 16, 17, 18. Okay, so we should have 4 workers. Okay, what is the range? Okay, remember the range is the largest value minus the smallest. Okay, so for that, we're looking here. 42 minus 16 equals 26. Okay, and then the next one says, would you consider this distribution symmetric? Okay, again, symmetric looks like a nice bell curve right down the center. I would say definitely not. If you look at our shape here, you definitely have a tail on this one. Okay, and the tail's on the right-hand side. So we could say that this is not symmetric, but rather it's skewed to the right because the tail is on the right. Okay, and then this one, okay, they get more and more in depth. okay, where you really have to interpret. This says the mean or the average age for workers 22 years old. Why is this average not representative of a typical worker? Okay, why does that not represent the whole population? Okay, so if you look, 22 is right here. Most of the data is below that value. Okay, and the reason is because of all of these, okay, these outliers. Okay, so the majority of workers are younger than 22. A few older outliers skew the mean or the average, meaning it makes the average higher. Okay, feel free to rewind, rewatch, and then we will look at exercise 2. Okay, this one I know you can do on your own. Okay, this one says a farm is studying the weight of a baby chicks after 1 week of growth. They find the weight in ounces of 20 chicks. The weights are shown below. Construct a dot plot on the axis given. Okay, you are literally just plotting these points. Okay, you're just stacking the dots. Go ahead and pause, try it on your own, and come back to me. Okay, now that you've tried this, let's see how you did. Hopefully, as you went through, you could have either made a frequency table, or you could have just crossed them off as you went. Okay, something like this. There's a 2, put a dot above the 2. There's a 1, a 3, a 4, and you could have kept going. Okay, there's 2 more 2s, right? We just stack them. A 3, a 1, 5, 3, 4, 4, 5, 6, 3, 8, 5, 4, 6, and a 3. See how you did? When you're ready, flip the page. Okay. The most complicated part about this one is part A, so we'll at least do that together and then we'll see where we go from there. Okay, so this is a survey is taken by an insurance company to determine how many car accidents the average New York resident has gotten into in the past 10 years. New York City resident. The company surveyed 20 people who are getting off a train at a subway station. The following table gives the results of the survey. Okay, this can be difficult to read. Okay, this here means that 6 people got into 0 accidents. Okay, so there should really be 6 zeros, in our data. There should be 8 ones, meaning 8 people got into 1 accident, 4 people got into 2 accidents, etc., etc. Okay, so for part A, when they're asking you to calculate the mean and the median, we need to kind of write this data out to understand. Okay, so again, there are 6 zeros, 8 ones, there are 4 2s, 1 3, and 1 11. Okay, so the first thing we can do is calculate the mean. Okay, so when we add all of these up, okay, you should get 30. And then we divide by the number of values, which they told us was 20. Or you can add this up and see that it is indeed 20. And what we get as our average is 1.5 accidents. And then remember that the median is the middle value. Okay, so if there are 20 data points here, then halfway in the middle would be 10. So if I count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, Okay, I'm expecting it to fall right in between here. We just double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we are good. And because it falls between 1 and 1, there's no doubt in our minds the median is 1 accident. Make sense? Feel free to rewind and rewatch. Okay. And I think what I'd like you to do is parts B through E on your own, and we'll check it tomorrow. Good luck.